Hello and welcome to the second video where I will explain what is going on in exercise 14, which is the regulation of respiration. So specifically what we'll be looking at in this video is the negative feedback loop that is used to regulate respiration. Also, we'll take a close look at the lab activities. Those include hyperventilating, rebreathing, dead space, and exertion. And we'll take a look at the data and talk about how to read it. Okay, so we regulate breathing as a negative feedback mechanism. So it has your typical components. It has a sensor, an integrator, and a effector. In this case, the sensors are chemoreceptors, and there's two places that we find those. There are the peripheral. Those sense changes in hydrogen and carbon dioxide. They really only detect oxygen if it's extremely low. And those are located in the carotid artery. And then the central, those are in the medulla, and those sense changes in hydrogen. The integrator in this case is what we call the respiratory control center in the brainstem, which is located in the medulla or pons area. And then the effector are our respiratory muscles, so those include our diaphragm and our intercostals. So what are we really regulating when we regulate respiration? Well, it's blood gases. So there's an equation that we will rely on to understand how this works. And so what we see in this equation is we have carbon dioxide and water, and through the enzyme carbonic anhydrase, those can be used to produce bicarbonate and hydrogen. And so hydrogen will affect the acidity of blood. So if hydrogen is high, then pH is low and it's acidic. And if hydrogen is low, then pH is high and it's basic. So let's take a look at the lab activities we'll be doing this week and how we expect those to affect our blood gases. So the first exercise we'll be doing is measuring the result of hyperventilating. So hyperventilating, that's basically taking a lot of rapid, short breaths, and then we will recover and we'll see what happens in the data. So what do we expect to happen if we hyperventilate? Well, if we hyperventilate, we increase the amount of oxygen that we're taking in, so that in turn decreases the amount of carbon dioxide in our blood. One thing that's important to know about carbon dioxide and hydrogen is if carbon dioxide goes up on one side of the equation, then we expect hydrogen to go up on the other, and vice versa. So in this case, if carbon dioxide decreases, then hydrogen ions will decrease on the other side of the equation. That will cause an increase in pH, or a more basic blood, and then the response is for the integrator to slow down respiration and decrease the depth of breathing. So the equation would look like this. If we decrease carbon dioxide, then that shifts the equation towards the reactants in this case, or towards the left. And so we see the hydrogen ions in this case would also go down. The next activity is rebreathing. So in this case, imagine you've got a bag and it's closed, and you put it over your mouth and you breathe in and out of that bag. And so what we're essentially doing is rebreathing the air that we already breathed. And eventually, if you did this long enough, you would die. But we're just doing it for a temporary amount of time. And what we expect to happen is carbon dioxide should go up because we're going to be breathing in a lot higher concentration of carbon dioxide. That would increase the hydrogens, which would decrease pH, so we would now be in a more acidic situation. And the response to that would be to increase respiration. So we would start breathing more to make up for it. And so the equation in this case would cause a shift towards the reactants, or a shift towards the right, where if carbon dioxide went up, then we would see more of those things be converted to bicarbonate and hydrogen. The third exercise that we'll be collecting data from is what's called dead space. So essentially, this is what can happen if you breathe out of a snorkel, or if you take a large tube from your mouth, you have increased dead space. So traditionally, we have a little bit of dead space in our trachea and the parts of our airways that don't exchange gas. So in that space, stale air can sit. Well, we're going to extend that space. And this should have a similar effect as rebreathing, where we should see an increase in carbon dioxide, which should increase hydrogen ions, decreasing pH, making it more acidic. And we should see the response of, again, increased respiration. And we should see a similar outcome from our equation. And then the last thing that we'll be collecting data from is exertion, or what we call exercise. So we'll be measuring the effect of exercise. And in this case, we've got a slightly different mechanism in place. It's not the negative feedback mechanism that regulates these other situations. In this case, it's a feed-forward mechanism. If you recall from way back in the beginning of the semester, we talked about feed-forward and how that will affect certain stimuli. And in this case, it would lead to an increase in respiration, or we expect it to increase respiration. And there's no gas exchange there's no changes in gas levels that would be occurring in the artery in this case, in the arteries. Okay, so how do we read this data? Well, if you take a look at this, this is sort of what your data should look like that you'll be analyzing. So remember, we've got these events here, and they show where an event starts and ends. So in this case, we're looking at hyperventilation. And then again, we have our tidal breathing. We have the beginning and end of the hyperventilation, and then breathing normal again. And so we can use this icon to measure certain waves, and then our data should appear down here. I hope this has been helpful. Thanks.